So yeah, thanks a lot for inviting me. Today I'd like to share a little bit about what we have understood through those 3 years of startup that I have experienced. We have designed specialized computer vision image recognition systems for our clients. And we have implemented different things in research and in engineering to solve image recognition, to solve our clients' problems with image recognition technologies. So it's not the truth, it's just based on our experience, but the goal here is to let you know a few things and to give you a few takeaways that you can take with you and that I hope will be helpful. So I'll be short about Deepomatic. In the company, we are 18 people. We have been created 3 years ago. We build specialized image recognition systems for our customers, which means that they are all different from one to another. And to do so, we develop a platform that lets our customer take their data and create their own algorithm that works the way they want to solve their own problem. And the goal is to empower our customer with a solution where they are the owner of the dataset they produce, they are the owner of the algorithm they produce, and so they can move forward and embrace the AI revolution to change the way they work and to develop new services or new productivity gaps. So the typical kind of problem that we met in the real world and that can be solved through image recognition are the following ones. The first one, it's a problem in the world of highway. So you have tolls, and the goal is to understand only with images of car, the category of the car that will be billed at the toll. So you have 6 categories from the bike to the huge truck, passing by the car or small trucks or a middle truck. And so it's a classification problem, very simple, six types of vehicle, and you need to determine which type of vehicle enter in the toll to bill it properly. The second kind of problem is a problem of infrastructure maintenance. You want to be, when you audit your infrastructure, you have experts going on the field, and they are going to assess if your steel structure is corroded, and to determine if it needs to be repaired. You can do it with a float of drones and centralize all the infrastructure audit with computer vision, explaining whether or not this steel structure should be changed or repaired. And the last one is in the world of e-commerce. You have product, and you can, if you want to develop, to automatically tag your product in order to make your product pages, or to develop better recommendation engine. You can use computer vision to tag the images, and this is the type of problem that can be solved through the technologies. And when we started Deepomatic, one thing is that just I wanted to tell that when we have complex sales cycles, and when we face clients, they always ask us, okay, so but how do you deal with the competition? Are you better than Google or Facebook at deep learning, at computer vision? And they really overrate the importance of research and development. And they never talk about which type of software do you develop, how does it work, is it robust? And it's something that usually our client doesn't take care. So today, this is why I wanted to explain a little bit that approach. And so 3 years ago, we started by working a lot on research. We wanted to be over state of the art. We wanted to implement new kind of algorithm, new kind of science, and we hired very good deep learning researcher, and we started to work on disruptive approach. At that time, we worked a lot on fashion. And for instance, if you want to build the Shazam of fashion, so I take a picture of your jacket, and I want to find similar jacket in the e-commerce.
FirstMark Capital.
Yeah, your sweater. You might try to develop this kind of technology. So in those images, the top and the down one, you have a pair of images with the same product that is represented inside. The same dress, the same hat, the same jean. And so it's pair of images. You have hundreds of thousands of pairs of images, and you want to develop an algorithm that is able to understand that there is the same image, the same product is in the real world image and in the e-commerce. It could be game-changing in the world of fashion visual recognition. So we worked on it for several months, I think 6 to 8 months, and finally, unfortunately, didn't give the expected result. And we are a seed stage company, so we cannot afford to work on those type of technologies for 2 consecutive years. It might work, but we simply had not the time. And we needed to try other approaches because the risk of not achieving the result was extremely high. So we tried 3 different types of approach to solve the problem of Shazam for shopping, and it was actually not working. It was taking too much time, and this was extremely stressful for the entire company, but also for the research and development team. So after that, we changed the way we did research. We understood after 1 year that it's almost impossible for a small company to compete with state-of-the-art algorithms that are produced by Facebook or Google or all the giants that works with hundreds of researchers every day to develop the next generation of deep learning framework. And we thought, okay, but to solve all those type of problems I talked in the beginning, actually we had a lot of questions and we had a lot of intuition. And we decided to change the way we do research, and this is a little bit complicated. It seems complicated, but instead of doing huge and very ambitious things, we decided to develop a lot of small experiences to have incremental improvement over what was already available. And we did a lot of experiences. Like if you double the size of your data set, what is the impact on the accuracy of your image recognition algorithm? If you change the deep learning framework, how evolve your accuracy as well? And in the world of image recognition, you build data set. So manually, you label images. If you work on the quality of the data set, if you have like almost no mistake versus a few mistakes, how does it impact the quality of the artificial intelligence you are building? All those questions, we had intuition, but we had no answers. And it was taking a lot of time in the product department to decide what was the next feature to implement without being sure, without having answer. So instead of research, we did a little bit more development, incremental improvement, and this was much more effective. And a few interesting things that we discovered through that new approach is that it's an example of a result we had by comparing a different type of framework for different type of problem in food recognition, fashion recognition, for instance. And we understand a few things. First, even though some neural networks are deeper than other one, or even though they are more recent, they behave differently on different type of problem. So when you are talking about food recognition, maybe ResNet is the best framework. But if you switch to fashion recognition or car recognition, another framework like GoogleNet might be better. So it was very important for us to test a lot of different approaches and to develop script to automate the test for different type of problems. The second very important feedback that I can give you, and I'm 100% sure, it is that in the world of computer vision, in the world of image recognition, it's a very open-minded world. Most of the discoveries are available, explained, open source, and you can use the code. So it's much more interesting to build over what already exists than to develop new approaches, at least for a startup of 20%. And the third major understanding that we had is that when you develop very specialized systems that are trained to solve a specific problem, such as the type of the category of vehicle entering in a toll, you don't need a huge data set. For this example, with 10,000 of images of cars and trucks, we reached 95% of accuracy. And this accuracy is already better than what exists actually today on the toll, where maybe you don't know it, but there are still humans that monitor part of the results in the automatic doors. So 10,000 images, 95% of accuracy. Very quickly, we could try different type of framework, and it resulted in an increment of a few percent. And we could increase the size of the data set. Of course, it's always a solution to get better results. And we reached 98%. Very interesting result for the client. So my point here is that when you do smart moves, small but smart moves, the dataset size that you need is not the bottleneck of the problem. Even if you have 1 million images in that dataset and you need to label it manually, if you have 5 seconds per image, you can make the calculation. To produce the dataset, it will cost you 50,000 euros, which is a super small cost compared to that problem, and especially for the client. This problem is worth tens of millions of euros for Vinci Autoroute. And so, yes, it's something very, it's a key finding. Like if you develop specialized systems, the dataset, in our opinion, might not be the problem. But in the real world, it's not about your training dataset and your evaluation dataset. You will implement something in the highway, and the environment will evolve. You will have tempest, rain, snowstorm, but you will also have new type of cars that are very strange and just in between the car and the small truck. And your artificial intelligence will steal little by little. Its performances will be reduced. So if you want to have something, an intelligence that, like a human, is able to evolve, you need to design, and we are now entering into the engineering part of the talk, you need to design human-in-the-loop systems, where whenever the artificial intelligence does a mistake, you can immediately correct it and allow the user to go through the toll. And by correcting the mistake of the algorithm, you increase the size of the data set, and you improve the accuracy of your artificial intelligence day after day. And yeah, another finding, another interesting thing, it is that most of the time, for big companies with operational problems in the real world, you need to have something that is backed by humans for two reasons. It cannot fail, and it needs to evolve over time. And the second point of artificial intelligence in the real world, it is that it is not allowed to fail. There is no way your system is down and it's not possible to build a user and you will have in 15 minutes 400 kilometers of traffic jam. This is not something not possible. So engineering is absolutely mandatory to develop systems that with a level of availability that is 100% or almost 100%. And for that, you need to have a very strong deployment team. Like how do you implement your algorithm, your artificial intelligence on premise in all over France in all the different tools. So it's also something that is extremely critical. So finally, I would conclude by explaining that we understand that it's not like two different types of approach. You can use what is available. You can improve it little by little. You can twist it to your own need. And then the key of a successful project is to implement it into a complete system where you can deal with data collection, labelization, manual labelization for building your data set, training your algorithm, deploying your algorithm on premises, improving it with the time going, and all this is included in what we call our platform that we build day after day. So thanks a lot. This is a funny slide that I like to show, a joke about computer vision. And if you have any question, I'm very happy to answer.
Thank you very much, Augustin. This is great. Thank you so much. Anybody have an urgent question? Otherwise, I'll get going on my side. All right. Get your questions ready. I have a question for you about, I understand, I get the implementation part, the incremental, I get the pragmatic approach, I get the non-failure when you're in the real world. How does scalability work in all of that? Because if you start, I thought the whole purpose of artificial intelligence and working on that is having incredible scalability and learning much faster. If you're putting humans in that process, aren't you creating a bottleneck in terms of the ability to develop in the real field and even theoretically?
Yeah, very interesting questions. In our world, for that specific example, actually what they have today, it's a mix between a magnetic system that weight your car, lasers that get the height of your car or truck, and it fails like 10% of the time. So you have already humans behind camera, and where the system is not accurate, they correct the result. So everything is already implemented, and if you design something that is more effective for the client, maybe they have hundreds of people working on that you do not see, but that are already working. It will just reduce the number of people they need to solve that problem. And I would say that for that specific project, it's already operational. For other type of project, it's a good question, and if you need something to be perfect, it will be hardly scalable. But sometimes 90% or 95% is enough, and you can like deploy your system in everywhere.
Yeah, except that if you're at the border and you're letting people through automatic systems, it can't fail. You can't let people through your borders. So there's a number of things, and what you're addressing here is more of the the gathering, the exactitude of the gathering of information more so than the treatment of the information. Is gathering the information, if the sensors don't sense right, then you have an issue. But if you have that perfect gathering of information, do you need humans to absolutely treat the information after? Is kind of curious.
The scalability, the operational scalability of what we are doing is related to that question also. Because the good thing with image, it's like image and videos, more or less, it's always the same format of raw data. So whatever is the sensor, we treat the same kind of information to solve the problem. But at the other side, we always need to have, so far, we always need to have humans labeling the data to develop a third system that bring values to the customer. So for that, we have actually a team in Madagascar that works with us. They have been working with us for more than 18 months now. It's always the same people, and they are used to deal with those type of problems. Sometimes it's not possible. When you work in the field of, we have clients in the field of medicine, and of course, it's not possible to outsource the expertise of saying, is it a cancer or not? And here you need actually to have experts working on your software to build a data set. And it's, of course, it's not a deal breaker, but it's something that everybody has to understand. It's big impact, big reward, but it takes some energy to build.
Okay, thank you. Questions? I've got a question over there, Alexandra, on the third row in the back.
Can we learn more about your experience in open source? Because to me, it's like a new R&D, a new way to do R&D. It's just an outsourced way, because you still improve the algorithm when you work on that.
Okay. Which type of, because we have done a lot of different type of experiences and training. So which type of details do you want about things that we have discovered in image recognition?
So when you shared about open source, you were more saying that you were using the open source and you stopped your in-house research and development?
Yeah.
And this is maybe what you referred as engineering?
Yes.
But actually, did you have R&D experience by using open source? Because to me it was like R&D, but outsourced R&D. Of course, I would say that every day you have tons of papers, and we benefit from whatever is done by Facebook, for instance. They publish a lot of different things, and it's true that it's not anymore on our side research and development, but more implementation of papers of research that we find to be the most interesting. So every week we conduct a paper reading, and we try to gather whatever is available and to discuss about what is the most interesting things to implement in the platform. But we really benefit from other sources of research and development. Thank you.
All right, Augustin, thank you very much. Unless there's one last question. Oh yeah, one more question in the back there, and then we'll move on. And yes, Augustin will be at the cocktail after, so you can
Thank you
ask
for
him
the
a whole
talk.
bunch of questions.
I just have a question about the deployment. What kind of technologies you use actually?
Okay, the question was which kind of technology do we use for deployment? So today we are able to manage to deal with three type of deployment technologies very easily. The first one is cloud technologies. So it's the most simple and the most scalable one. So we work with AWS and with Google Cloud
And it's for sure very effective, but not very disruptive. For a lot of problem, you need to work on premises, and so we work with local servers, just big servers, big computer, where we deploy the systems. Everything is done with containers, like Docker technology, and so we can change the type of hardware we use. And the last type of deployment is, I don't know if you know, but it's really the future. It's super exciting, even if it's very technical. The last type of hardware where you can deploy your intelligence is small hardware that are designed for this type of technologies, such as NVIDIA Jetson and also Intel Movidius. So it's very, Intel Movidius, it's the size of a USB key, and it's very powerful. So it can be like plugged to a camera to make it clever. And it's really evolving fast. It's very important for us to keep the pace with this type of challenge as well.
Augustin, thank you very much. Fantastic.